Hey, Vsauce, Michael here. In 1826, this became the very first photograph ever taken. And in 1992, this became the very first image ever uploaded to the web. But how many photographs have we all taken all together throughout all of history? Well, 1000 Memories investigated this very question. They took a look at the number of digital cameras currently in use, typical usage of a digital camera, as well as the amount of analog film and film developing supplies used by the industry ever since the 19th century. Tabulated all together, they estimated that we have taken 3.5 trillion photographs, 4 billion of which were taken this year alone. We are snapping more photographs than ever before because of the proliferation of easy-to-use, affordable digital cameras. In fact, we take 4 times more pictures per day than we did 10 years ago. Or think of it this way. Today, every 2 minutes, humanity takes more pictures than we took all together in the entire 1800s. Of course, the 1800s were a long time ago, but if we take every year from the invention of photography until today, 10% of all of those images, a tenth of every still image recorded of our world was taken in the last 12 months. That's a lot. But even crazier is the fact that a fifth of these images, 20% of them, all wind up in the same place: Facebook. Facebook is huge, but to put it in perspective, you Vsaucers are huge. If all of us got together in one place and claimed independence, we would become the 152nd largest country on Earth, right between Guinea-Bissau and Trinidad and Tobago. But Facebook, with its 1 billion users, would be the 3rd largest country on Earth. To take a quick, dark detour, of those 1 billion people on Facebook, it's estimated that 30 million of them are now dead. And in 100 years, it's estimated that 500 million of the people on Facebook will be deceased. Facebook Stories offers a really neat tool where you can click on a country and then see what other countries most of their Facebook friends live in. It's fun to see what countries are most connected to which others, but this whole thing brings up the question of degrees of separation. If you were to take 2 random people on Earth, how many friend of a friend of a friend of a friends would you need to connect those 2 people? Well, in the real world, it's a little difficult to figure out because we don't know who's friends with who, and there are a lot of people. But luckily, mathematics has come to our rescue. Watts and Strogatz showed that you could calculate the average path between any 2 random people quite easily. In this equation, the n stands for the total number of people in the population, and k stands for the number of friends each person has. If we assume that each person has, say, 30 friends, and we assume that 10% of our population is too young to have actual friends, it turns out that you can connect any 2 people on Earth with only 6.6 connections. Theoretically. Of course, in the real world, we don't all have the same number of friends, we don't all have 30 friends, and isolated groups make the average much, much higher. Of course, there are non-real world places where these connections are easier to follow. For instance, Facebook. Last year, Facebook's data team released 2 papers showing that amongst all Facebook users at the time, the average distance between any 2 random users was only 4.74 friends. Twitter is even tighter. It's been shown that any 2 random users of Twitter are connected by only 4.67 friends, though some studies have shown it to be as low as 3.5. Numbers like that can make impersonal crowds seem quite intimate. But one of my favorite things about crowds is how smart they are. Wisdom of the crowds is a fascinating phenomenon where the collective knowledge or guesses or estimations of a big group of people, when averaged, are better than one individual person working alone. A good example of this is trying to guess how many jelly beans are in a jar. Some people will overestimate, while others will underestimate. But collectively, each member cancels out the errors of the other, and the group average estimation winds up being smarter than the sum of its parts. The BBC's demonstration of this is fantastic. I've linked it down in the description. It's worth watching. They had 160 people guess the number of jelly beans in a jar. The guesses ranged from a few hundred to tens of thousands, but the average of all 160 guesses was 4,515, only 5 beans away from the exact answer. It's amazing to think that in a large enough group, the errors and shortcomings of everyone else, no matter how annoying they are individually, actually can balance and correct our own shortcomings. It feels good, though a little bit strange, to think that in a group, it's possible for nobody to be correct, but for everybody to be right. And as always, thanks for watching.